Hello, everyone. Thank you for joining us today for our event on bootstrapping, tracing, and metrics with OpenTelemetry on GKE. My name is Lauren, and I'm the content manager for the Google Cloud community. And I'm thrilled to be here today with Kyle, Sujay, and Josh, our product leaders and technical experts who will be taking you through the content today and answering your questions. So before handing it over to the team, just a final reminder that questions are encouraged. So if you do have any questions, anything to say or to share with us, please drop that into the YouTube chat box and we'll be sure to get to it either in the chat or at the end of the presentation. We also had a few pre-submitted questions that we'll cover as well. And for any that we don't get to, we encourage you to utilize the community. So the links to that are in the YouTube description where you can join, engage with each other and Googlers in forums and discussion styles, and you can stay up to date on future events like this one. All right, well, I know we have a lot to cover today, so with that, I'm going to hand it over to the team, but don't be shy. Let us know where you're joining us from, where you're tuning in, any questions you might have in the chat, and let's dive into the content.
All right, I'll introduce myself really quickly. I am Kyle Benson. I'm a product manager with the Cloud Ops Suite.
Hi, I'm Sujay Solomon. I'm also a product manager on the Cloud Ops Suite. Josh?
And I'm Josh Surratt. I'm a software engineer at Google, technical lead around telemetry, collection, movement, that sort of thing. And I'm on the OpenTelemetry technical committee in open source, so I contribute to the core project.
All right, so I'll get us started. Just in terms of today's topics, we'll start by just covering observability and goals that users and our customers typically have with observability, both from the perspective of the end users of observability, but also from the perspective of somebody who's setting up your observability systems as well, like what are their goals. Next, we'll talk about certain components that are critical for what we're going to talk about within GKE from OTel and OpenTelemetry. Next, Josh will talk about an ideal architecture for deploying OTel on GKE. And there's a super exciting demo following that where you'll see some of that in action. And then we'll get into some more deeper dive topics like tuning your observability systems. And then we'll conclude with the takeaways and Q&A as well. So kind of getting into the observability side of things, if we take a look at the user goals, there's really three overarching user goals that I would say are common when folks are looking to set up observability. One, applications today are really the lifeblood of many, many businesses. It's not an optional thing. It is absolutely a necessity these days. Given that, if there are problems with your application, your end users might be affected, your business might be heavily affected by that. So detecting those problems as early as possible and mitigating them becomes of utmost importance, right? So you may not necessarily exactly debug the problem and resolve the actual problem that's occurring, but you want to do enough mitigation so that you're able to get production back up and running as quickly as possible. Oftentimes, mitigation can be done by rollbacks that are performed. Perhaps something was deployed that's faulty. Identifying that and rolling that back many times is the first line of defense. So that's common. And being able to do that quickly is one of the goals with observability. Now, the second one, root cause analysis. Now, some incidents, you may not be able to resolve them just by mitigating it by means of a rollback. You may need to actually do some serious debugging and understand what's going on and possibly even write an emergency fix and deploy that into production. That's one case. In other cases, even if there's a problem that you rolled back, the problem still exists in a certain release or a version. So being able to detect and debug what the issue is there, getting the context from the incident that happened in production, and doing that root cause analysis so you can prevent that from happening at a later time becomes very critical as well. And third is sort of proactive prevention, right? You want to continuously get better at your observability so that you're preventing a lot of these incidents rather than mitigating them or doing things like emergency fixes and so on. So you may need to increase fidelity of some telemetry. You may need, for example, you may want to introduce new points in your code from where you're generating trace data, things like that, that you're proactively doing to prevent incidents from happening in the future. So those are some of the user goals that we typically see with customers with observability. In addition to user goals, when you're setting up observability, you're thinking about your users who are doing things like incident response, but you also need to think about your system goals for observability because, for example, applications grow, the number of services grow, or the load on those applications and those services grow. So as that grows, your observability also needs to be able to scale in concert with that. Now, while observability systems do need to grow, you do run into a point where you may need to kind of balance things out where the overhead of observability cannot get to the point where it's affecting the end user's user experience as well. So those are things to keep in mind around scale and observability systems. In addition to scaling, you also want to make sure that your observability systems are configurable. So what that really means is, you need to have control over what telemetry gets generated from where. And then in addition to that, also where it's being sent to. So for example, you might be in the midst of an incident. Perhaps you are not necessarily always catching all of your trace data. Maybe your sampling rates are pretty high. You may need to alter and change that sampling rate when an incident is happening so that you can increase the fidelity of telemetry that you're receiving from certain services, so you can possibly debug and figure out what exactly is going wrong with it. So configurability of observability systems, especially dynamically, is very important. Third one is sort of flexibility and openness, right? So a lot of customers that we speak with today don't want to kind of get locked into a specific vendor's offerings. That oftentimes can happen if you're instrumenting things using some sort of a proprietary library rather than something that's open. And then also being able to rely on an open community where you can go and ask questions and you're actually able to see the code. That gives you a lot of confidence in the observability system that you're using. And finally, the ecosystem that kind of goes along with these open frameworks and such that are out there for observability gives you a hand. You're not just on your own. There are other large enterprises also using these same technologies, and you can rely on that community as well. So those are some system goals that we often see when folks are building observability systems. Now, moving on to the GKE side of things. So GKE, or Google Kubernetes Engine, of course, is Google Cloud's fully managed Kubernetes service that you can use to deploy and operate containerized apps at scale. Now, our point of view at Google, containers power today's most innovative applications and businesses. And we truly believe that it will unlock even greater business transformation and innovation in the next few years. So of course, this is backed up by Gartner's prediction that by 2027, over 90% of organizations will be running containerized apps in production, which is a 50% increase from what it was in 2021. So that's some massive growth there. But given the growth of these mission-critical and business-critical applications on GKE and K8s in general, first-class observability of the services that are running on GKE becomes an absolute necessity here. So that's sort of where OTel comes into play. I'm already saying OpenTelemetry and OTel, but OTel is short for OpenTelemetry. I think most folks that are in the observability space probably know that. It is the second most active project under CNCF, the Cloud Native Computing Foundation, so right after Kubernetes itself. Lots of other popular cloud native projects like Prometheus also reside in CNCF. Now, OTel is a very active project with lots of companies contributing to it, including Google. Now, we also remain a top 5 lifetime contributor to the project. In fact, the Open Census project, which was part of the 2 projects that were merged into OpenTelemetry, was actually one that was started by Google initially. Now, OTel focuses on the 3 popular forms of telemetry data that are commonly used in cloud-native apps. So that's traces, metrics, logs. In addition to this, there's also some ongoing work to expand OTel to cover things like events and profiling as well. But that's work in progress. Beyond this, as with any open source projects of this scale, there's a thriving community that many of the users lean on for things like expert advice, and they come and share their experience of using OpenTelemetry for the entire community's benefit. So I would definitely urge folks to, if you're interested in becoming a part of the community, join the CNCF Slack project, and you can look for OTel related channels there. Now, specifically in terms of what's offered in OTel, as I mentioned, OTel was born from the merger of Open Tracing and Open Census. So because of that, a lot of the trace-related components in OTel are probably the most mature. Right after that is metrics, with things like the APIs and the protocol all reaching stability. Logging is probably the least mature part, but there's a lot of growth and focus there right now to bring it up to stability. So what's maybe not in scope for OTel? OpenTelemetry has no current plans of expanding to cover sort of visualization or consumption of telemetry data. It's more about instrumenting it, collecting it, routing it, and establishing conventions so that you're able to use many different tools for visualizing it and so on. So we don't, OTel currently does not have any plans of kind of moving over to that side. So specifically, a component that's of interest today when we talk about GKE and OpenTelemetry is the OpenTelemetry operator for Kubernetes. So OpenTelemetry offers the K8s operator that we recommend using in the ideal OTel GKE architecture. So Josh will get into the specifics there, but this is a necessary component for what we're going to be recommending. Operators, of course, are extensions to Kubernetes that let you automate tasks that K8s does not automate out of the box. So it's a pretty common pattern that's established within K8s. So this particular OTel operator does 2 things. One, it lets you inject auto instrumentation into your workloads. So, maybe you're trying to adopt something like tracing or application metrics, and you don't currently have anything instrumented in your application. Auto instrumentation gives you a straightforward way of getting started with it. Now, it may not give you the highest fidelity of telemetry being generated, but it gives you something that you can kind of get started with. In a different case might be, perhaps you're using some sort of a vendor-specific instrumentation library today, or an agent. This is something that can kind of help you move from sort of the proprietary mode into the open world and adopt OpenTelemetry for your instrumentation needs. Second, the operator also deploys the OTel collector, which you can use to process your telemetry and route it to whatever backend you want to send it to. So in terms of installing the OTel K8s operator, there's really 2 simple steps. The OTel K8s operator does need the cert manager. So if you look at the install steps listed here using Helm, if you just walk through that should install the cert manager for you. And then once you've got the cert manager installed, you can then install the K8s operator using a kubectl command. The 2 repositories I've got listed here, the first one is all the OTel operator repositories that we'll be referencing in the architecture and the demo. And the second repo is a Google-specific one, which contains some of the samples that Josh will walk through today as well. So with that, I'm going to hand it off to Josh to talk about recommended OTel architecture on GKE, including a super exciting demo.
All right, thanks, Sujay. Yeah. So as Sujay said, we're going to walk through some architectures and things that are enabled specifically with this operator. It just makes this dead simple. So effectively, when you want to deploy OpenTelemetry, there's this component in OpenTelemetry called the OpenTelemetry collector. The OpenTelemetry collector is a process or server that allows you to send telemetry data to it. It collects it and sends it to different locations. Within Kubernetes, there's different ways of deploying things, but the operator supports 3 specifically we're going to talk about today. A daemon set, a deployment, and a sidecar. Each of these 3 has different trade-offs, and we're going to talk through those trade-offs, and then we're going to talk through our recommended architecture after that. So first, the daemon set. A daemon set is you can specify that you would like to run an OpenTelemetry collector on every single node or VM, right, within your cluster, or every single machine in the cluster, depending on how you have your K8s configured. So what this will do is every time a new node is spun up, an OpenTelemetry collector will be inserted there. It has some pros, right? You have an OpenTelemetry collector available on every single node, so you can get infrastructure metrics. You can get the host metrics to understand what is the overall CPU usage for that node, for example. You can get container logs directly from whatever container runtime is being used. Since you're running right there, you can just slurp up those logs and send them out the OTel collector. You can do local enrichment. We'll talk about enrichment, but effectively enrichment is I have a source of telemetry that's producing values, and I might want to add additional annotations to that telemetry. Like I'd like to denote this telemetry came from this node, came from this cluster, came from this pod, that sort of thing. I can do local enrichment right there and then say, all of the telemetry that comes to this collector, I'm going to add a label that says Kate's pod equals my name, that sort of thing. The other thing that you can do is you can use this thing to limit your overhead per node. So if I send all of my telemetry through the local collector, right, I have effectively limited the amount of memory that I'm spending on observability from this collector. Daemon sets there's a blessing and a con to them. You effectively, when you declare them, you declare a certain amount of memory and CPU they use on the node. So you're controlling your overhead. The downside is they always use the same amount of CPU and memory. So if you have a particular node that's very, very, very chatty, very, very heavy on the CPU, you have the same amount of overhead as the node that basically isn't doing much, right? And if your node starts to scale heavily in a vertical fashion, these daemon sets can start to run into issues. This is a common problem with daemon sets. So let's talk about another alternative, which is a deployment. If you use a deployment, what happens is you specify a number of instances of the collector you would like to run, and K8s will provide a kind of network proxy that will treat it as a service, and you can route telemetry to various collectors. You can actually control how that routing works. There's lots of configurability there. This has the benefit of you can scale telemetry horizontally across the whole cluster. So if I'm using this OpenTelemetry gateway mode, is what they call it for deployment, I can fire telemetry at this service, and I can make sure that I scale out as my cluster grows overall. And those pods can be scheduled on any particular node. I don't have to force fit them in every single one, right? So I get cluster-wide scale. What we tend to do with deployments as well, another thing that we recommend is you can do things like have this deployment have the same routing and also give it persistent disk. So for example, if I am trying to send data from a K8s cluster somewhere else, like an external data storage system, like a cloud observability vendor, I might want to actually put some persistent storage on each of these that I can deal with network outages. So let's say my K8s cluster, drops off the network because I'm running it local, I have inconsistent network, or my remote storage system might have some hiccups, right? I can allocate some persistent storage here, and I can make sure that I have a buffer of data, right? That I will be able to retry when the network comes back around. And then let's go to the actual third scenario here, which is a sidecar. So a sidecar approach is every time someone defines a new pod that needs to run, I will actually attach a process beside it of OpenTelemetry with some overhead. What this allows you to do is you can actually scale based on the amount of things you're scheduling, but the downside is you have a lot of duplication. So every single pod gets its own collector. Every single pod has a set of overhead. It's actually one of the most expensive, but one of the most controllable ways of running OpenTelemetry collector. What we're actually going to recommend here is a architecture that actually involves daemon sets and deployments. So for a variety of reasons, we recommend deployments as your go-to initial architecture. It allows horizontal scaling. It allows you to control the flow of the data within your cluster as at a cluster-wide level, as the most amount of flexibility for how you can scale out. It interacts with Kate's horizontal scaling very well. It's a very solid choice, but it has some limitations, right? We don't get that infrastructure observability because we can't guarantee that we have a collector running on every node. So we might not get the observability we need. So to solve that, we just do both, right? We will run a daemon set, which has that local OpenTelemetry agent, and we will take that agent set and we will put, the daemon set or OpenTelemetry as an agent, and we'll point that at the gateway, right? Or at OpenTelemetry as a deployment. And so this gives us a little bit of both worlds, right? We can use the daemon set to get our host observability. We can use the deployment to actually send data to this observability backend of our choice. And we can scale both independently based on needs of our cluster. So for a little bit of extra overhead, we get a lot of flexibility with what we do. The other thing that's nice about this is we can choose for any individual pod if we write data to the local agent to have that local overhead, or if we write directly to the gateway if we need to scale beyond what the local overhead allows. And we're going to give you a quick demo of this. So first I want to show you, this demo is actually demonstrating all of the features of OpenTelemetry and the operator that we had before. So the most important thing for you to understand is we're demoing really, really simplistic web applications. This is the Python web application. What you see here is just a standard Flask application that returns a hello world JSON string. If the environment variable called next server exists, it will call into a next server. We do this so we can just show off distributed tracing. Within this, if we come back to sample apps and we show you the, we'll say Node.js, you'll actually see the exact same application, but this time written in Node.js. So if the next server environment variable exists, we forward to it. Otherwise, we return hello world, right? And so what we've done is we have set up, actually, if we could come back to the slides for a second. We have set up a sample application where we have Python talking to Java, talking to Node.js, just to show you, that these are simple services, no shenanigans, and this auto instrumentation that OpenTelemetry provides to give you that observability for systems that you might already have in place, right? Each of these is talking to a daemon set OpenTelemetry collector locally. Those daemon sets are talking to an OpenTelemetry gateway, and then that gateway is sending data to Google Cloud Ops as just the simplest option for GKE. But again, you could send it to any storage of your choice. One fun thing to note is since we're running a daemon set for the hotel collector, you'll see a fourth OpenTelemetry agent when we look in the demo that is actually just reporting on host metrics and sending it to the gateway for the gateway's own pod. All right, so let's head on back to the demo. So this is actually the data that we're getting out of the demo here. You can see that we have right here, we're getting HTTP server duration metrics from all of these different servers that are running. This is a heat map graph where the hotter colors mean there's more traffic in that particular region and less traffic in this region. These little lines that you can see kind of highlighted here, that's the 95th percentile. This is the 99th percentile. The 50th percentile is down here. And these little dots are actually traces that are occurring in the system. So if we click on one of these, you can see actually trace details. You can see, there was a call to slash, and then it follows through the different chain. We can actually go into a better trace view here, and we can see that for the same trace, we have that slash where it is a Python service calling a Java service, calling a Node.js service. Another fun thing I want to call out that's just a beauty of OpenTelemetry is you get a lot of rich instrumentation data. This K8s cluster name, K8s container, K8s deployment name, this is information that is enriched via the OpenTelemetry collector and the OpenTelemetry operator. It is added into what OpenTelemetry provide out of the box by the OTel operator. So if we wanted to search for things on a particular K8s cluster and look for any latency related to a cluster, we could identify it, for example, and do searches. So you can see here, this is from the Node.js OpenTelemetry HTTP instrumentation. This particular span here comes from Java. I think we have to go here. Oh, sorry, I skipped it. Yeah, Java. And then this particular span here comes from Python. Different languages produce different attributes, but there's a set of them that are all consistent here. So cool. Lastly, I was just going to show you what this looks like in Kubernetes. Apologies, I forgot to preload this one. So you can see here inside of Kubernetes what the operator has done, right? We have that agent collector. I mentioned there's 4 of them because we have 4 different nodes running. I do want to mention that this is running on GKE autopilot. So what that means is we don't know how many nodes our cluster has when we start up. It actually just spins up nodes on demand as we roll out new services. So currently we only have 4 nodes. We have one node that is running the gateway collector. This is that OpenTelemetry as a deployment. We have then the other 3 nodes that are running our Node.js service, our Python service, and our Java service. Finally, the OpenTelemetry operator itself is actually right here. You can see it running as an instance. What's nice here is if we were to say, look at a particular agent, inside of here, we can actually then check and see how much CPU and memory it's using. So if we wanted to understand what our overhead of instrumentation is, we can check how much we've allocated and we can check how much it's using. Right now, again, we're just doing home requests with curl. We're not really overloading the system. And so we're not actually spewing a lot of observability data. So we're not getting a lot of overhead either. Another important thing here is if we check out the logs, you'll be able to actually see things coming through OpenTelemetry collector. We have configured all of these to have a debugger enabled that tells you, I just launched this many metrics. I just launched this many logs. So for example, right here, we exported 4 different metrics with actually only 3 different data points in them. Okay. This is actually super invaluable for debugging. If you're trying to debug what's going on with OpenTelemetry, you can actually look at each individual collector and see what's going on. This gateway collector, if I show you the logs here, there's going to be a teaser for something we're going to talk about in a few minutes, which is this. You can see every once in a while it's loading a new configuration for sampling, and we'll talk about that. As we talked about, one of the needs of observability being very efficient and configurability and responding to incidents as they occur. So let's step back to the slides. All right. So how did we configure this, right? This demo of all these things running. We have a CRD is I think it's a container resource descriptor or resource descriptor of some sort. I actually forgot the acronym because I just use CRD so much. But this is a definition of an OpenTelemetry collector that we'd like the operator to run. and it's a little bit of YAML. And so when we define this, we've defined two. We have that agent one, which is the daemon set, right? So we specify the mode as daemon set. And then we have a gateway one, which is a deployment. In this CRD, it's almost as simple as you define a spec where you say what mode you want to run and then provide an OpenTelemetry configuration or OpenTelemetry collector configuration. In that collector configuration, what we're doing for the agent is we're actually making sure it exports to the gateway. So we're saying all of the data coming from the agent is going to get routed to the gateway. By default, when you deploy one of these, you get a name-collector service that is created within Kubernetes that will host all of the standard OpenTelemetry ports and protocols. So 4317 is gRPC, 4318 is HTTP. I just have those memorized, but they're also well documented. The next thing we're going to provide is the auto instrumentation configuration. So this is describing when I want to instrument that Python app, that Java app, what should it do? And we're providing two options here. So export to agent says, I would like this particular service to send data to that local agent. Export to gateway is, well, maybe this service is too big for the local agent to handle. I'm going to send it directly to deployment, and I don't need any of the benefits the local agent's providing. The other thing you'll notice here is you can define propagation. So this is how trace is sent from A to B to C, the trace IDs. We're using W3C standards in OpenTelemetry, which is the trace context, trace parent baggage, or trace parent header, and the baggage header. Finally, we're configuring a sampler. So this is how many traces do you want it to generate. Parent-based trace ID ratio is saying if someone else has decided to sample this trace, I will also sample it. Otherwise, send 25% of all traffic. I'd like to generate a trace and send it to my backend. All right, and lastly, we take our existing service, our deployment of, like, say, Java, and we add an annotation. You know, there's a kube control command where you can, or kubectl, depending on how you pronounce it, where you can actually just add this in one line to any existing deployment. But effectively, there's this instrumentation OpenTelemetry IO inject dash language, and you specify which instrumentation configuration to use for your auto instrumentation. So in this case, we've actually set them all up with export to agent. So all of them are going to a local agent and then going to the gateway from there. But that's, again, you can configure that. You can change it just by updating this annotation. With that, we're going to start working on tuning. So inside of OpenTelemetry, there's this notion of what we call enrichment, which is how do I take telemetry that I'm getting today and make it better? Like, what can I do to make it more usable, more refined, or somehow better for my needs? And there's three processors we're going to talk through. One is called a resource detection processor. A resource in OpenTelemetry is the thing producing the data. So if I am that Java service, right, you noticed when we looked at it in that trace view, there was a label that says, this is the Java sample service, right? Where does that get generated? How is that generated? The OpenTelemetry resource is what's kind of responsible for that. A resource detection processor allows an OpenTelemetry collector to add information to a resource based on various things it can look up. For Kubernetes, and specifically for GKE, there is a GCP resource detection processor that will detect all of the aspects of Kubernetes from GKE that you might need and add them as labels to telemetry that flows through. And that's one of the ones we're using. So for example, Kate's cluster name, Kate's pod name, that sort of thing came from the resource detection processor. Next, there's a thing called a transform processor, and this lets you do arbitrary transformations of data. So if OpenTelemetry is producing data with an attribute that you don't like, you can change it. If you want to arbitrarily add attributes, you can do that. If you'd actually like to remove content, you can also do that with a transform processor. We'll walk into that in a little bit. Finally, there's this thing called a Kate's attribute processor. This is a more sophisticated mechanism of doing attributes than the resource detection processor, with a few nuances and caveats that we'll walk into in just a bit. So this is what the configuration looks like for the OpenTelemetry collector for these. Enrichment is pretty simple. You say, I would like to have resource detection. I would like to make sure that discovering this metadata, this signal information that I need to add, times out within a reasonable manner, so I don't just hang there waiting to understand my environment. And then you pick which ones you want to use. So for Kubernetes on GKE, we recommend using the environment detector and the GCP detector. Next, the transform collector config. This allows you to define a transformation that will run as things flow through your pipeline. Here is actually a recommended configuration for logs for if you're sending to GCP, where actually we recommend there's this GCP log name that we use internally if you're sending to cloud logging. This will actually set that log name to be the same as the OpenTelemetry service name, which actually just improves your ability to search and find things in OpenTelemetry inside of cloud logging if you're using that. Finally, we have this K8s attribute processor. Now, this one's a little bit more sophisticated. This particular instrumentation works only with a daemon set collector. So you need to be running locally in the node, and you need things pointed at you directly. What this will do is it will hit the API server of Kubernetes, pull in a bunch of information about where things are running, and then based on the IP address that you are connected to the collector with, it will annotate a lot of very specific information about your pod for you. It's not necessarily as necessary with the OpenTelemetry operator, because the operator will provide some of this out of the box, but it's a kind of advanced and sophisticated way of doing this. Why does this need to be a daemon set? Well, this actually places load on the actual control plane and API of Kubernetes itself. By default, what this node from environment variable is doing is it's saying, instead of hitting the API server and pulling all of the information about your entire cluster into one individual instance of the OpenTelemetry collector, just pull in information about the node I'm running on. And so this helps alleviate some of the scalability concerns of hammering the API server as part of your telemetry plane, and reduces it to a per node instance, which is far more scalable. And again, this is a kind of an advanced thing for users. All right, so next up, we're going to talk a little bit about routing. Routing is something that you can do where I have two systems of record, right? I want to store some of my data in maybe a local Prometheus instance, and maybe I want to send some of my data to a remote Prometheus instance, right? You can do this. Not only can you do this, but you can actually choose what to send based on, say, labels or attributes of the content of the telemetry. So here we're actually have a routing processor, and we define two exporters. We define one which uses Prometheus remote write to write to a local Prometheus, and we define another one that will write to Google Managed Prometheus. But again, this could be any exporter whatsoever. Again, we're using that same language that we saw in the transformation processor, but in this time with a few special keywords, route, to say, if you see something that looks like this, send it here. Otherwise, send it there. And these statements are followed in order, kind of like a routing table. Next, we're going to talk about limiting your telemetry. This is another thing that you'll see us running in our sample repository is we recommend using a memory limiter. What this does is it helps, assuming observability is best effort. This means that when we hit pressure, we would rather have our website continue to run than have OpenTelemetry or your observability run you out of memory and cause production crashes. So the way this works in the OpenTelemetry collector is once you hit a memory limit, right? If you hit a memory limit for a particular spike, we will start dropping data until we're below that spike. So this is a mechanism that you can use to reject data coming into the collector and prevent that overhead from hitting your whole system, right? So we can kind of drop it as it comes in.
Hey, Josh.
Yes.
Sorry, I was just going to jump in really quickly because there was a prior question sort of around this topic. There's two of them, so I'll show them together. But the first one was, do you measure the overhead of resources needed for implementing OpenTelemetry? And the second one was, is there a way to calculate expected memory consumption? So I'll hide both of those, but I think this might be a good point for you to address them.
Yeah. So this is one of the ways that you can address the memory consumption. If you saw in the demo, is there a way to measure what memory consumption is? It's actually very, very hard to understand memory consumption without actually looking at your system, right? So like I said, there are times where your system's going to be incredibly chatty, and there are times where it won't be. A rule of thumb here is when I have when I'm using traces or logs, the amount of memory and CPU that I need is relative to the amount of traffic I'm getting. And so if I see a spike in traffic, I need a corresponding spike in observability kind of to hold those signals. With metrics, it's a bit more subtle because generally with metrics, there's more of a fixed overhead. They're reported at an interval. They're aggregated. So your underlying system producing the metrics might pay a little bit of this, but you'll have a consistent overhead of metrics throughout the system. So metrics are a little bit easier to understand and account for how much you need to flow through. But there's still sometimes issues there where if the system's under high CPU load, your ability to kind of tell it to go grab some metrics right now, you're fighting with that computation. So it can still slow down. In terms of do we measure overhead from OpenTelemetry? Absolutely, we do. There are, for actually the auto instrumentation, there's a set of benchmarks you can see where we compare running a system without OpenTelemetry and with OpenTelemetry. You can see what the overhead looks like. And we also there's a whole benchmarking working group in OpenTelemetry trying to expand what benchmarks we do run for the collector and give you better numbers and more significant, easier to understand things for architecting. Yeah, so great questions. Hopefully that answered them. In this particular instance, though, the memory limiter is not necessarily changing the overhead of OpenTelemetry. What it's doing is it's preventing OpenTelemetry from ever causing ooms and outages. Okay. All right, let's look at the next slide is how do we scale? Again, since we have that gateway collector, it's a deployment. So we can actually scale by specifying the number of collectors. Another thing that we recommend is using horizontal pod autoscaler, where when we send that OpenTelemetry collector config, we can say, here's the minimum amount of collectors I need, here's a maximum, and the cluster itself will actually automatically update the number of OpenTelemetry collectors you need when it detects issues with CPU and memory. If you're using that memory limiter, that can interact with this in fun ways. That's why we absolutely recommend the memory limiter for the agent side. For this gateway deployment, we recommend this autoscaler, and then you can even use it with kind of custom metrics. So but that's all normal Prometheus HPA kind of features, and you get all of that available here. So last thing we want to talk about is Jaeger remote sampling. So this is from the standpoint where we're talking about telemetry, we're talking about configuration and openness and the ability to respond to a problem in production. This gives you the ability to actually fine-tune the sampling of traces. I want to make sure that this particular service is sampling at 10%, this other service is at 80%, and maybe I want to turn off sampling of this particular endpoint. This lets you do all of that. What we've done in this demo is we have our user pods are polling the OpenTelemetry gateway for configuration of sampling, and they poll every minute. Then we have that OpenTelemetry collector, and you saw this in the logs. It was actually polling the file system every minute to say, hey, do you have new configuration for sampling? The OpenTelemetry collector will actually serve a sampling configuration that's mounted via config map in Kubernetes and serve it out to our auto instrumentation. And this will allow us to actually change our sampling ratios and deploy it into production rapidly, on demand, when we need it. So what does that look like? Again, more YAML, more CRDs. Here's what the configuration looks like for the remote sampler. There's a config map. We've called it JRS for Jaeger Remote Sampler because that's the protocol that's being used, and that's the actual content of this file. And there is a sampling JSON file, which is JSON. And this JSON follows the Jaeger remote sampling format. There's a default strategy for sampling. We're setting it to say probabilistically sample 50% of traces. And we can go richer and say, all right, for the Java service, I want 80% of traces. More importantly, I don't want any traces when someone tries to grab Prometheus metrics. So set that to 0, right? And you get fine-grained control here across the board with that. Next up, we're actually going to change our OpenTelemetry collector config. We actually need to extend it to include the Jaeger remote sampling extension. So on the right, the collector config includes the Jaeger remote sampler, where to get the actual sampling JSON, and then we tell the service to use this extension and host it. Next, we actually have to update the ports that are exposed manually. This is because, by default, the OpenTelemetry operator will provide all of the ports that are generally OpenTelemetry. Jaeger is an extension, so now we have to provide all of them. You can see the OpenTelemetry protocol are the first two, and then this Jaeger remote sampler protocol is the next two that allow this to get hosted. And then finally, we update that instrumentation that was used for auto instrumentation to say, okay, we're going to set our sampler to be Jaeger remote, and we're going to point it at the gateway collector at that new port that's exposed. It's going to poll every, well, actually in this case, sorry, I said in minutes. I'm polling every 5 minutes or 5 seconds, sorry. And we're setting a sampling ratio of 25%. So if this gateway is down and I can't connect to this whole system, this is the default sampling rate that would show up for that particular workload. And at the end of the day, we get the ability to push this configuration into our Kubernetes cluster on demand, and it will update live, it'll update within minutes, all of the configuration for sampling across all of my independent processes that are running, that are connected to this. Okay. With that, let's talk a little bit about takeaways. So first off, I think the most important thing we want to call out is the OpenTelemetry operator is trivializing setting up the configuration of your observability data plane here. If you looked at those CRDs that we're providing, they're simple, and a lot of these things are kind of conventions. Like I want, a deployment, a daemon set. It will, when I say I want a deployment, it doesn't just do the deployment, it does a deployment and a service. If I say I want a daemon set, it doesn't just do the daemon set, it installs a daemon set and a Kubernetes service that does node local routing, right? And it trivializes the actual full convention of what you really want to do. So you have one CRD instead of, the traditional like 3 or 4. The second thing is the OpenTelemetry collector in a deployment is your easiest to scale across the cluster, right? It's just, we know how to scale behind a load balancer. But let's augment this with a daemon set. That gives us that node local collection. It lets us do anything we need node locally. It lets us get host metrics. Finally, we can limit the memory consumption per node with this memory limiter. And it means that we don't we don't crash, and we let observability kind of hit its peak and not take down production systems or not cause, overflow pod looping fun. You don't get paged when your observability necessarily goes down, and you can handle it off band and scale it as needed. So during that heavy incident, you're not also dealing with observability crashing. Finally, Jaeger Remote Sampler is this beautiful thing that gives us fine-grained control over tracing. So if you needed to actually control tracing at the individual service or operation level, you have it. A few resources. If you're familiar about OpenTelemetry on GKE, we have some getting started blogs. All of this is using the OpenTelemetry operator GitHub sample. There's the cloud native Slack, which we actually recommend you join and ask general questions about the OpenTelemetry operator. Please also share feedback. Is this first link the OpenTelemetry operator sample repo, Sujay?
Correct. Yeah.
Okay, all of the code, the CRDs, everything that you saw in this presentation is in that first link. So if you want to know what code we deployed, you want example CRDs, you want to try to run this yourself, it is all documented at the top link.
Perfect. Yeah, no, thank you so much, Josh, Sujay, Kyle, for this presentation. And each of these links are in the YouTube description, so no need to type it into your browser or anything. You can quickly access those links directly from the YouTube description below. And we also dropped a few of them into the chat as we were going along. So please do check those out. And as you said, we'd love to hear feedback. Feedback is a gift. So if you have any suggestions for future topics or thoughts on today's session, we'd love to hear from you with that feedback form. With that said, thank you so much again, Josh, for this demo. Thank you, everyone, for sticking with us and for your questions. So we are going to dive into a couple of pre-submitted questions as well as your live questions from the chat. So please keep those going, and we'll be sure to get to them. All right, so our first question that we had is managed Prometheus absolutely required in order to export OpenTelemetry metrics to cloud monitoring?
I can take this. It is not absolutely required, but it's also not something that we would continue to recommend. We actually think you're going to get a better experience using Managed Prometheus. The Managed Prometheus and Cloud Monitor are actually the same backend, so you don't actually experience a loss of functionality or anything. It's not different. It's not you're not sending it to a Prometheus. You're actually sending it to the same backend, just with a view that looks like Prometheus. So we think you're going to get a better experience out of that.
Makes sense. All right, and then our last one here is this referring to head sampling or tail sampling? And any additional context around that, if you can provide, that'd be great.
Yeah, absolutely. So head sampling is when you make a decision to trace initially when a request flows into your system. Tail sampling is where you make the decision kind of after all of the spans of the trace have been generated and collected, whether or not to keep the whole thing. Head sampling is a little bit more efficient generally because you can make the decision early and you don't have to spend memory remembering things. Tail sampling, you actually have to allocate enough memory to hold the entire trace in your observability system until an event triggers that lets you either delete it or record it. We are only covering head sampling in this demo. There are tail sampling mechanisms available, but again, that includes you need your observability system has to be able to store that data. And depending on your load, that could be a lot of data. So we definitely recommend head sampling or some sort of pairing between head sampling and tail sampling.
Makes sense. Thanks for that explanation. Awesome. So we did provide some answers in the chat to a few of your questions, but there are also others that we haven't gotten to quite yet. So first one here that we'll cover is this was actually during your demo, Josh. So I'm missing how the trace is being forwarded. Is it somewhere across the code? So yeah, any additional information that you can provide there?
Yeah, happy to. I'm trying to go back to if we look at the CRD here in where's the slide?
Oh,
I think that was the maybe something that got lost when we were looking at the slides and the CRDs. Let's do this, and we're going to come back here. Come on. Okay, so in this instrumentation CRD, this is configuring the auto instrumentation, and you're declaring an endpoint. So we're saying, I want this to go to the agent collector, which is a Kubernetes service that is using it's routing to the local agent. But the way that's how that service is configured. Export to gateway. If I use this CRD, right, this would say I want a route to the gateway collector. Then when we actually annotate our service to say we want auto instrumentation, we pick which one we use. So I'm using this export to agent CRD. What the OTel operator does is when you go to deploy these pods in this service, did I lose internet or am I back?
We can hear you.
Okay, sorry. When I go to deploy these pods, it will actually update them with the configuration for where to send the data, and it will inject the auto instrumentation components. So for Python, that's a set of Python libraries that will be included before your Python app. For Java, that is actually a Java agent that will run. And that configuration generally is exposed via environment variables. It might be an actual file. That's kind of the details of the operator. But that's how the system is getting that auto instrumentation and pointing back to your collector.
Great. Thank you. Hopefully that helps answer your question. Okay, we had a few just recently come in. So how can HPA be set for pod with collected metric in GKE?
This is a great question, but I think we might have to link to some documentation here. So there's a mechanism to do that where you have I assume that, let me make some assumptions. So let me make an assumption that you're using HPA with GKE and you're using cloud monitoring or managed Prometheus. We have documentation on that under the managed Prometheus site for how to use that metric with HPA. We can link that to you, but I don't actually have a demo of that, so I apologize. I don't have anything ready, but it is documented, and we'll get that link in the notes later.
Perfect. Yes, we'll add it into the chat as we go along for some of the other questions. So why is OTel operator required cert manager?
This is another great question. So again, you can talk to the OpenTelemetry operator folks about this, but right now they're using Cert Manager to issue certifications to use secure traffic in the telemetry plane. So they can actually spin up the OpenTelemetry collector with an HTTPS cert that's been minted, and then make sure that the traffic that's going between them is acceptable and secure, right? So this is part of an ongoing goal to continue to secure your observability plane, because it's everything's a risk nowadays. You have to be very careful and be very secure. So, but that's actually what it's used for, is to secure that traffic.
Makes sense. Okay, we have just one more for now. So if you have any additional questions, we have just a couple of minutes left. We can sneak them in. In our GKE Dynatrace, or if GKE Dynatrace is installed, will it conflict when you want to do an OTel operator?
Another great question. I'm not familiar with what Dynatrace is doing from the operator perspective. I would suggest that it shouldn't conflict if it's not interacting with the OpenTelemetry CRDs, right? If it's trying to replace the OpenTelemetry operator, which again I don't know, you might have issues, but that'd be a good question for Dynatrace.
Yeah, I think one of the considerations there, Josh, right, is so Dynatrace actually provides support for OpenTelemetry, right? So I think it depends on ultimately, if you want, there may be in terms of, certainly speak with Dynatrace, but you have the option of using the OpenTelemetry collector to send those metrics and traces to Dynatrace as opposed to necessarily having them both. Well, that's one of the great things about OpenTelemetry is it allows you to sort of standardize on a metrics and trace format today where lots of vendors support that. The examples Josh showed today, we're really focused on sending it to Google Cloud's telemetry suite. But when you're setting that exporter and you're setting that standard of OTel, it allows you to have some flexibility and distribute that data in a consistent fashion, regardless of the end vendor where you're storing it. So, it may be overkill in terms of depending on what your goals are, and it might be worth talking to Dynatrace about to see how they recommend ingesting OTel.
Makes good sense. And thank you. We have added that resource that Josh was describing on HPA. So do feel free to check that out, and hopefully that's helpful. And, just speaking about, I think as the last topic or question that we'll take, going off of the benefits of OpenTelemetry, Kyle, that you were talking about, we did have a question around what is the benefit, if any, of using OpenTelemetry with my existing monitoring tools. So I know we provided a bit of a response here in the chat, but I think this is a good one to end on for the team if you have any thoughts or recommendations here before we close out.
Yeah, I mean, I'll Josh, do you have any quick comments? And if not, I have a couple of quick thoughts. But yeah, so I think at the end of the day, Google fundamentally believes in open source and sort of providing the ability to use open source tooling both in our product and with third parties. And one of the big things about this is depending on what your existing tools are, right? So if you're using like a Grafana Prometheus stack and you're very happy with that, you may not need OTel, but the ultimate sort of thing here is OTel does seem to be a standard that lots and lots of providers are standardizing on, right? And so there seems to be a lot of growth in that community, as well as the number of vendors adopting that. And so it's kind of ultimately a personal or an organizational decision, but the ability to have a consistent standard and pattern for what your data looks like coming out of, from an operational and observability perspective, I think is a great equalizer for a lot of people. It unlocks a lot of value and will improve sort of standards going forward. So it's ultimately your sort of choice, but we see lots of customers who are ultimately trying to do this and moving towards this to avoid vendor lock-in. And then again, I think as Sujay said earlier, have a clear standard, understand what's going on inside your observability, and know how things are actually being generated.
I want to call out one other thing. We talked about the needs of observability. And one of the things that we talked about earlier was, going from detection and mitigation to going to root cause analysis, which is where we see kind of, expanding with trace going. And then that final bit, which is what we call prevention, right? And one of the things that OpenTelemetry is doing, which I think is slightly innovative for open source, right, is it's open, but it also gives you the story of I can start with auto instrumentation, and we didn't talk about it today, but I can then instrument manually with APIs, and I can actually augment the auto instrumentated baseline provisions with more observability as I need. And so that starts to become compelling. And if it starts to bleed through open source and you see, gRPC is providing OpenTelemetry, right? That now my tools come with it out of the box, right? So that's another benefit of it being open.
Great points. Amazing. Well, we are at time. So thank you so much, Kyle, Josh, Sujay, for this information, the demos, and answering all of our questions. And thank you, everyone, for joining us. Pulling up those resources and what's next, again, just as a reminder, and we'd love to see you at one of our upcoming events. We have a lot coming up around AI and another session on GKE in November. And stay tuned for this space. We may have these folks back for more around OpenTelemetry as well. So stay tuned. With that, any final thoughts or recommendations from you all before we close out today?
No, thank you so much. And thanks again for attending.
Awesome. Thank you, everyone. If you do have any final questions, please feel free to add them into the Slack channel or the Google Cloud community, and we'd be happy to follow up with you there. All right. I hope you have a great rest of your day, evening, or wherever you are in the world. Thank you.